Good morning, everyone. We are here today with Raquel Gonzalez from BCM Materials. They are partners in the Multifund project, and we will get to know a little bit more of what are the activities that will be developed in WorkPackage 2. So, Raquel, can you start by probably introducing yourself and also providing us some more information about what is really the main objective of WorkPackage 2 in Multifund?
Okay, of course, Rita, thanks for the introduction. I am Raquel Gonzalez. I'm the project manager and the project coordinator of BC Materials. I'm also the responsible of the communication of the center. And my background is I have a PhD in physics of materials and nanostructures. Regarding the work package 2, in where we are the leaders, this work package is mainly focused in the advanced additive manufacturing materials for multifunctional performance. We have a different range of objectives. We have the specification, definition, and redesign of multi-materials and multi-functionalities realized by the multi-fund material in WorkPackage 2 and processes development in WorkPackage 3, and also for future additive manufacturing demonstrators in WorkPackage 5. And the second objective is the material development and manufacturing incorporating nanotechnologies. We are going to develop at least 3 new additive manufacturing material precursors using nanotechnology. We are going to develop also at least one applicable solution precursor feedstock. We are going to optimize precursor raw material synthesis and manufacturing methods thereof. And we also are going to pre-characterize the development of additive manufacturing materials before, the raw materials, and after additive manufacturing processing. And the last objective of this WorkPackage 2 is a roadmap for upscaling and industrial implementation for manufacturing of new materials.
We now have Danielle Salazar to tell us a little bit more about the partners that are also engaging and supporting the work on this work package. Because, Danielle, tell me if I'm wrong, but all this work by yourselves would be much more difficult if you didn't have the collaboration with other partners in Multifund. Is that correct?
Yes, of course. In fact, the gain that we obtain from this project is through the collaborations among the partners. What we want is to design and produce multifunctionalized wires and powders through the nanoscale modification. So these materials will act as additive manufacturing feedstocks for WAN and APPV technologies, respectively. So WAN means wire arc additive manufacturing, and APPV is atmospheric pressure plasma deposition. These are a couple of advanced 3D printing techniques used to fabricate 3D metallic parts. So I will describe a bit about activities. For example, the first task is the design of phases for multi-materials. This work is led by LKR, and here the activities related to the design concept of use case demonstrators with integrated multifunctionalities. For the second task, we are coordinating these activities. The name of the task is Development of Nanotechnology for Materials for Additive Manufacturing Powders and Wires. And here we are going to prepare precursor ceramic nanoparticles by high energy ball milling. And when required, we use some surfactants to further reduce particle size and increase their dispersion prior to their mixture with additive manufacturing feedstocks. These feedstocks are like powders and wires, depending on the technique. So in parallel, we also will develop coatings onto the additive manufacturing powders, mainly metallic and diamond-like powders, using physical vapor deposition powder coating. This task is led by people from LKR and in collaboration with legal. So for the WAN processing, several wires will be produced at the lab scale and demonstrator level also. The main development focus will lie on compounds of particles from the previous task and metal matrix, especially aluminum and copper. So LKR will use it. Will use CIP, casting, or on semi-solid type subtraction processes for the generation of billets, and then the solid extrusion will provide round profiles from which Miguel will draw some wires. For the next task, related to the development of coatings for embedding optical fibers by additive manufacturing, Infotech is going to take the lead of this activity, and they will develop protective coatings for optical fibers capable of withstanding high temperatures and still providing full sensing functionality during additive manufacturing processes. A small furnace at DLR will provide simple testing procedures without the need to feed single fibers into single layers during one processing. And finally, for the last task, this is the task 5 about the development of in situ compositions led by people from Cranfield. The activity is basically the wire-based system from using the wire-based system from Cranfield and Lortec from the next WorkPackage. They will use to investigate the properties of single layers being deposited by 2 or 3 different metals in the same layer for in situ alloy, thus capable of alerting locally the chemical composition of deposit material.
Thank you very much, Daniel. I think it was a good explanation of the tasks that are going to be performed in the framework of WorkPackage 2. Thank you very much for your contribution.
Thanks to you, Rita.
Good morning, Eduardo. Our WorkPackage 2 development and work will support the remaining work packages, and what are the links to the work that other partners are also doing in Multifun?
What we do is to create these new materials. We test the properties and we listen to the partners to build additive manufacturing processes, the structures for the demonstrators. So what we do is to, for example, we start with powders with material and we coat a really thin layer in the nanoscale, and we test that the properties have been improved.
Thank you very much. I think it was a good explanation, and I'm sure that without WorkPackage 2, we wouldn't be able to reach our goals in Multifun. Thank you. Thank you all of your colleagues that participated in the interview. And I think that's it for today.